All right, let's talk about it. We're diving into one of the biggest, most persistent debates in back-end development, Node.js versus Go. And look, we're not just going to talk about simple benchmarks here. We're going to get into what really truly matters when you're building something for massive scale.
You've definitely heard this one before, right? It's the kind of statement that gets thrown out on Twitter or Hacker News, and it starts a total war in the comments. It's so simple, so absolute, it's presented as if the case is already closed.
But what happens when we step out of the clean, perfect world of benchmarks and into the messy reality of production? You know, with Kubernetes doing its thing, multiple databases, and just this absolute fire hose of traffic coming in. Does that simple little statement still hold up? That's the real question, isn't it? Because getting the answer wrong could literally cost you a fortune.
Okay, so to really get to the bottom of this, we have to start with how these two things actually work. I mean, their designs, their core philosophies, they are worlds apart. And that, right there, is where the whole story begins. And here it is, the big difference. On one side, you've got Node.js with its single-threaded event loop. Think of it like a world-class plate spinner, just masterfully juggling thousands of connections at once without dropping a single one. It's all about concurrency. Then you have Go, which is built for true parallelism. It uses these super lightweight things called goroutines to spread the work out across all your CPU cores. It's a completely different approach, and this one distinction, well, it changes absolutely everything. So let's think of Node.js as the ultimate party host. It's incredible at greeting thousands of guests at the door, handling network requests, as long as each chat is super quick. Hi, welcome, grab a drink. It absolutely shines with that kind of I/O-bound work, like fetching data from a database or calling another API. But what happens if one guest corners the host for a really long, deep, philosophical conversation? You guessed it. That's a CPU-intensive task, and it blocks the host. The line at the door stops moving, and the whole party grinds to a halt.
Go, on the other hand, is totally different. It's like having a whole team of hosts. When that one guest comes along who wants to talk philosophy, a CPU-heavy task like encryption or compressing a big file, Go just says, no problem, Bob, we'll handle that for you. It dedicates a specialist to that task on a separate CPU core, and the main party keeps going without skipping a beat. It's a natural for heavy computational work. The only catch? Well, managing a whole team can sometimes be trickier than managing just one person.
And this brings us to what might be the single most important point of this whole conversation. Seriously, the question is never which one is faster. That's the wrong question. The right question is faster for what? Because performance isn't about the tool itself, it's all about the job you're trying to do.
Okay, just picture this. You have a service, and maybe 80% of its time is just spent waiting. Waiting for a database to respond, waiting for another API to send back data. That's what we call an I/O-bound workload. And during all that waiting time, what are Node and Go doing? Pretty much the same thing, twiddling their thumbs. The raw speed of the runtime just doesn't matter that much when the real bottleneck is sitting somewhere else on the network.
But what if your service is doing the exact opposite? What if it's constantly crunching numbers, encoding huge JSON files, or processing images? That's a CPU-bound workload. Now, the runtime isn't waiting on anything. It is the bottleneck. It's the star of the show. And in this scenario, Go's ability to use all those CPU cores, well, that gives it a really significant measurable edge.
And this code just nails it, doesn't it? In any real system, your code is just one link in a much longer chain. If your database is slow, it just doesn't matter how screaming fast your API code is. Trying to optimize the runtime before you fix that database? Yeah, it's exactly like strapping a rocket engine onto a bicycle. You're not going to get where you want to go any faster. So if raw requests per second isn't the whole story, then what are the senior engineers and the architects? What are they actually looking at when they have to make this call at a huge scale? Well, the answer has a lot less to do with raw speed and a whole lot more to do with money and how things feel to the user.
But before we get to what the experts are measuring, we have to bust a really common myth. This one trips people up all the time, especially with Node.js. You hear the word asynchronous, and your brain just automatically jumps to parallel, right? You think it means Node is doing a bunch of things on the CPU at the exact same millisecond?
Yeah, that's just not how it works. It's false. Node's async model is all about concurrency. Think of it like a single, incredibly talented chef who can start one dish, turn to another, stir a sauce, and then go back to the first one, all without getting mixed up. That's concurrency. Go's model is true parallelism. That's a whole kitchen full of chefs, each one working on their own dish at the same time. Now, Node can do parallelism, but you have to go out of your way to set up worker threads. It's not the default.
All right, Myth number 2. This is another big one. It's the idea that just by choosing Go, or any faster language, you're magically guaranteed a scalable system. And again, just nope, false. The language you choose is such a tiny piece of the scalability puzzle. I promise you, a well-architected Node.js system with good caching, smart load balancing, a solid database design, it will run circles around a poorly architected Go system every single day of the week. Scalability comes from your architecture, not your language choice.
Okay, let's talk about something really tangible, money. Let's say a service built in Go uses about 40 megs of memory. A similar one in Node.js, because of the big V8 engine it carries around, might use 90 megs. So that's a 50 megabyte difference. Doesn't sound like a lot, does it?
Well, it's not small when you start multiplying. Let's say you're running 400 pods of that service. Suddenly, that tiny 50 megabyte difference has turned into 20 gigabytes of extra RAM that you are paying for every single month. This is how small, seemingly minor inefficiencies explode into very real, very big infrastructure costs at scale.
So this is why the pros look way beyond simple requests per second. They obsess over things like P99 latency, because that tells you what the experience is like for your unluckiest 1% of users. They're calculating pod density. Basically, how many services can we cram onto one machine to save cache? They're dissecting tiny garbage collection pauses that can cause those weird, frustrating stutters. And they're timing cold starts, because how fast your service can spin up to handle a sudden traffic spike, that's absolutely crucial.
Okay, so we've torn down the tech, we've looked at the real-world metrics, so how do you actually choose? Let's put together a simple framework you can actually use.
So when should you reach for Node.js? Well, you should seriously consider it for any I/O-heavy APIs. Basically, if your main job is just moving data from one place to another. It is absolutely fantastic for real-time stuff like chat apps using WebSockets. And let's be honest, the ecosystem is just massive, which means you can build things incredibly fast. And probably the biggest reason, if your team already knows and loves JavaScript, sticking with Node is a massive win for productivity.
On the flip side, when does Go make more sense? You should definitely pick Go when your service is doing a lot of heavy lifting on the CPU. Think data processing pipelines, high-performance internal tools, basically any time you need to squeeze every last drop of performance out of your hardware. And of course, for any system where keeping memory usage super low is a top priority.
And all of this brings us to the final and maybe most important trade-off. This is where the decision stops being just about tech and starts being about business. So here's the big question to leave you with. Looking ahead, in a world where cloud servers get cheaper and more powerful every year, but good developers get more and more expensive, what are you really optimizing for? Are you optimizing for runtime efficiency? Or are you optimizing for developer velocity? Do you pick the tool that saves you a bit on your cloud bill, or the one that lets your team build and ship features to your customers faster? The answer to that question, well, that might be the most important performance metric of them all.